3. Lecture 3, as I said at the beginning, it's a tricky one. It really requires you to do a little bit mathematics in order to analyze networks, and to be more specific, in order to analyze network performance. So lecture 3 is all about, or week 3, it's all about network performance measures. Some of you asked me about the book. What book? For example, this chapter is not in the book. These are my personal notes. You will not find it explicitly in the book. You will find some of it from the book that I mentioned, the outline, but most of it not from the book. Okay, I think I mentioned here chapter 3.6. So for those of you asking what chapters and so on, be very careful. It's not 100% from the book. Okay, let's start with how are networks used today. I'm going to start with two commands, very important ones, which are remote, RSH, and RCP. So real quick, these are networking commands. I'm going to give you examples of networking commands which you need to know. If we had a lab, later on you might apply them in the lab as well, just for you to practice them. I already mentioned maybe a bit about the ping command as well. Maybe I'll talk about it a little bit more. So again, you could use networking commands in different contexts. You could use networking commands in different contexts. For example, RSH and RCP, again, important commands. Just to give you an idea. Anybody have an idea what these do? RSH and RCP. Again, remote. Yeah, again, these are on the command. Okay, not reverse server, remote. SH, come on. Remote, no. Okay, you're guessing too much. So remote shell, typically. So you log in to the specific computer. So what this does, allows you to basically remotely log in. This is the computer name. This is the computer name. So I'm remotely logging into this computer name with authentication. The plus A meaning this is the attribute. These commands have different attributes. So with authentication, and I'm going to execute a command called ls, list. So I'm listing, basically, I'm listing the files on this computer after I got authenticated. So this is what it does. I like this. So I could remotely log in to the computer with authentication and execute a command. You can see how easy. For those who are saying, watch a lot of movies, oh, I'm a hacker, you know, I could hack computers and stuff like this. In case you don't know, for hacking systems, this is how it's done. You write scripts using shell commands that execute other commands in other computers, okay? So, and it's very interesting. I always warn my students, do not mess with me. If you do, I could remotely log into your computer and simply delete your whole hard drive. I could do that, okay? So it's something we teach, actually. There's a course called System Programming, Advanced System Programming, which kind of introduces you to shells and obviously Unix and Linux and scripts, which I teach that subject as well. So interesting. So anyway, so yes, I hope you got this. So remotely logging in and executing a command. Let's do one more. What is this doing? I think we got the idea. You could see this is remotely what? Remotely copying, as Clark guessed. Remotely copying. As you could see, we have two. I'm copying my file, as you could see, from my directory, you know, to other directory, my file. That's as simple as it is. So basically, I'm going to copy my file into the other directory in Hope user account. So this is another user called Hope. Okay. And the name of the file is still my file. Again, as simple as that. So I could use the command prompt to copy from one user to another in one click. Again, not drag and drop and so on. It's command line. So you can see we could use it for autonomous system. We could use it for network file system. Network file system meaning, again, a file system within the network. Like if you work in a company or even I think in university, You know, you have a C drive, a D drive, you have an H drive sometimes. This is like a drive that we have, and I could put files in it and have access to it. That's what we call the network file system, okay? Again, it's like a hard drive within the network. So you could have an operating system which is distributed. Again, instead of having an OS on a computer, you could have a distributed operating system as well. So these are all uses of networking. What else? We have two other commands. We have the ping command, very important. Pay attention. I love this. I'm going to have some questions in the final on this as well. So you need to understand this. So I want you to play with it yourself. Google it. Try to execute the ping command. See how it's working. Okay? So it could be as simple as pinging a computer to see if it's alive. Or, this is where it becomes interesting, we could add some attributes to it. Okay? So play with the attributes. Play with the attributes. Okay? So the ping command is the easiest command. Very easy. Ping computer name. Okay? Again, I could put the machine name or the computer name or the IP address. I could also put the packet count, meaning how many packets you want to ping. There is a default, of course, the default, but you could decide how many packets you want to ping. It's fine. You can check out what the default settings are. No, it doesn't have to always be 32. But yes, you could figure these out. You could play around with it. You could say I want to pick it 5 packets, 6 packets. Could be 64 bits, for example, 64 packets. And yes, definitely there are default values. This is basically how many packets you want to send or you want to ping. How many times you want to ping, you know, basically. The time between the packets, you can also specify that. You could specify the time between packets, meaning I send packet 1. How much should I wait to send packet 2? Typically in milliseconds, right? How do you want to format the results? What else? We could specify the sequence number, the number of the packet. You want to see the sequence number. What is the number that the packet has? For example, 1, 2, 5. It's like the packet ID. The packet ID, if you think about it. Okay? Okay? So this is important, not very important. The most important for me, again, you could check out the others. Getting the answer. Of course, the delay, the time taken. This is what you will get, the time taken. Let's talk about TTL. Very important. Okay, I'm going to put the star next to it. So TTL is time to live. This is very important. Time to live. What does it mean? It's basically the number of routers a packet is allowed to go through before being destroyed. Many people think time to live or the TTL is time. It's not time. This is basically number of, let's call it switches. I have to go through before I get killed. Why do we do that? We do that to avoid cycles, to avoid loops. So if I'm here, you know, let me just show you what I mean. Suppose the packet went like this, and went like this, went like this, went like this. So what happened here with my packet? What happened with my packet, guys, in the picture that I drew now? This is the packet. It went on a loop. So it might go back again and again and again, right? Which is crazy. That's so bad. How do I make sure this doesn't happen? We put a counter. So a TTL is like a counter. A counter that gets decremented, every time you go through a switch, usually a router or a gateway. So I decrement it, you know, typically, again, 64, 255, that's the maximum. What does it mean? 255 meaning 255 gateways and routers, kilometers away from each other. If the packet goes more than 255, because I'm decrementing it, you would know that it got killed. So it will kill it. The system will kill it, will ignore it. This is again to avoid packets that are going for infinity. You know? Yes, yes, Mishka. Indeed. When the TTL goes to 0, the packet is killed, is ignored. So we don't forward it anymore. The gateways will not send it anymore. We'll simply delete it. Okay? So I like this TTL. It's nice to know the TTL as well because we can play around with it. So network designers, when they're kind of looking at network performance and so on, they use the ping command in clever ways. It's not simply as ping whatfa.com. Yes, you could ping whatfa.com. It tells you the delay. But I could do more fancy stuff with it if I want to. So please go ahead and play around with this. See what you can do with it. Not too advanced, but at least check it out. Again, you could use sustworks.com if you want to use a web portal and many others. You could use a web portal in order to do ping and get some kind of nice graphical user interface. Or you could do it on the command prompt. Okay, of course, we like to do it on the command prompt better. But yes, you could tell you how many was sent, how many were received, the average, the minimum, maximum, stuff like that. This is very basic. Of course, you could specify how many packets. You could specify how many packets you want to send as well. Okay? So this is an example of a ping command. You could see ping. Let's look at this real quick. You could see -N2. Okay? 1450. Okay? And then IP address. So you could see again, check out these apps. I don't want to confuse you too much, but obviously this is kind of easy. N2, what does N2? N2 means, guys, number of packets. Yes, number of packets. So as I said, you could specify how many packets you want to send. The size of it is 1450. The size of it is 1450. Okay, bytes, 1450 bytes. And I'm pinging the specific IP address. And I get the details. You could see the details and the TTL. You could see basically did not go through any gateways. So the first packet had a TTL of 32. The second packet has a TTL of 32. Again, what was received, what was lost, and it gave me the delay, which is around 0 milliseconds. Okay? Very nice, very simple. Let us look at another command. Okay, again, you can see the N count is how many packets I'm sending. The L is how big the packet is. Okay, how big the packet is, how many packets I'm sending, and how big the packet is. The default is 32 bytes. Very good. So another command, which is the trace route command. The trace route command. Again, very similar to the ping command. The difference is the trace route allows us to see how the packets are traveling. So it shows us the path. So instead of me just knowing how far the delay is for each hop, it also tells us how is the packet traveling. So it started in Dubai, then went to Saudi Arabia, then it went, I don't know where, for example. So it tells us how the packet is traveling. So I could get an idea about the switches in between. Very similar, it will give us the delay as well. So I give it the host name or the computer name or the IP address. It counts how many packets is being sent and how are they going. So you could resolve host names, which means it will tell you the name instead of the IP address. Because sometimes you tell me it went to 127 or 192.15. It doesn't mean much to me. If you say resolve host names, it will tell you the actual name if it can. What is the actual name? Okay. So this is an example of some old trace route we've done. My old computer, I think. Maybe I was in Canada then. So trace route, yahoo.com. You could see, again, this is how many, 1, 2, 3, 4, 5, you could see how many hops. Again, the first one took 20 milliseconds, then it took 30 here, then it took 50. It started in Ottawa. If it could resolve it, it will. If it cannot resolve it, it keeps it as an IP address. then went to here. Again, 1, if the host is online. 2, and traceroute gives us more information, basically how the packet is being traversed. And I love these 2 commands. In the final exam, at least 10 marks usually comes on them. Not like how to call them, it's more like how to think intellectually. I've been telling you, you know what? We hired you for a company, you're a manager in a company, and you want to use these commands and maybe give you another command. How can we use these commands in order to figure out the path or something? You know, I want you to think about them. Please, please, please practice them. Not very advanced, but try them out. See what you could change in them. Try to design. Say, you know what? I want to check out the delay here, here, and here. Okay. Yes, you could do trace route. You could use trace RT. Depending on what version are you using. Typically, you have both. But again, check it out. It's not a big deal. Okay. Let's move on. Any questions so far? Any questions?
No.
Okay, thank you. Thank you for telling me. Thank you. I like you guys. Thank you. You know, like I taught some subjects before, you know, when we do the evaluation at the end, did the professor allow you to ask questions? No, you know, I'm putting it on the record. Any questions? Any questions? Please ask questions, you know, so that I want to make sure that I'm doing my part, allowing you to be honest. You know, it's very important to really ask questions very fresh. Don't wait for it. When you wait for it, it tends to kind of die out. Okay, so before we start, let's make sure we know the metric units. We know the metric units, okay? So again, we can go up or go down. Very, very important. Milli, micro, nano, pico, femto, atto, zepto, yocto. Okay, it sounds like Chinese when we come here, but cool. So you could see 10 to the power minus 3. As I'm going down, yes, as I'm going down, I'm dividing. So again, we are starting with, suppose seconds, just to make your life easy. 1 second. If I'm going basically down, so basically, if I want to convert, I have 1 millisecond. I want to convert it to second. 1 millisecond. I want to convert it to a second. What do? I divide by 1,000. Basically, I multiply by, yes, you need to memorize them. Yes, Sufyan, of course. These are basics of computer science. I mean, if you don't know these, it's very important for you to know them. If you're a computer scientist or a computer engineer. Anybody not a computer scientist in this course? Anybody? Not an IT? I mean, yeah, of course, these are your ABCs. These are your ABCs. Again, obviously, I would say stop at Pico. It's fine. You could stop at Pico. You could stop at Pico. It's fine, okay? So again, the idea is simple. If I'm converting millisecond to a second, I divide by 1,000. Micro to a second, I divide by 1,000,000. So it's another 1,000. So you can see 10 power minus 3, 10 power minus 6. Then I have nano, then I have pico. Let's stop at pico. The same thing when I'm going up. Here I'm going up. I multiply. 10 to the power 3, 10 power 6, and so on. So a kilo, again, could be bytes. A kilobyte is 1,000 bytes. A megabyte is 1,000,000 bytes. So it's 1,000 kilos. So it's kilo, mega, giga, tera, peta, exa, zeta, iota. Okay? You can see they're very similar. Here you have here iota. Here you have yocto. Zeta, zepto. So these are the big ones. So funny enough, guys, when I was teaching this course 15 years ago, we used to dream of having terabytes. You know, terabytes was a dream. I used to even make fun of it. I say the day will come, guys, where we have terabytes of data in our hard drive. You know, We used to, again, maximum we had megas and gigas then, 15 years ago, I'm saying. And now terabyte is something that everybody has, right? And I'm telling you, when I'll be teaching this course again, 5 years from now, we'll be in the exa range, okay? No. Again, Alan, these are all there. Again, these are there. I'm saying having them in your computer. Okay? Okay, that's what I'm saying. Having that to the common, to the public. Of course, they're there. Yeah, these are units defined. So hopefully 5 years from now, we'll get to the exa. You know, anybody has exa hard drive? Okay, I don't think anybody. And then we're going to get to the yotta. Imagine yotta, oh my God, 10 to the power 24. That would be a dream, right? I mean, it doesn't exist today. Of course, 10 to the power 24. Okay? Okay. So, very important to know at least kilo, mega, giga, tera. And again, up to tera is fine for me. Again, don't worry about it. To memorize, it's easy. From kilo to mega, then mega to giga, giga to tera. Okay? So when I'm going up, I'm multiplying by 10 to the power 3. So you can see 10 to the power 3, 10 to the power 6, 10 to the power 9, and 10 to the power 12. I'm multiplying. When I'm going down, milli, micro, nano, pico, again, femto, but let's stop at pico. We are multiplying by 10 to the power minus 3, which is meaning we're dividing by 1,000. Okay? I mean, do they exist? I don't know. Of course, I would say big hard drives of Google. Of course, they do exist. Even the Yotta, maybe in like supercomputers, hard drives, and so on, as servers. You know, of course, for the people. But obviously, for us, it doesn't exist yet. For PCs, definitely not yet. Okay. Okay. So once we figured out all these units. Let's do some examples, and we could take a break and then continue the second half of today. So what are some of the common network performance measures that you need to know? I'm gonna do 4 of them. We're gonna do some examples on them. Take a break and then do something called end-to-end delay, which is very, very important. Okay. Okay. Okay, so what are the 4 common networking performance measures? We have the bandwidth, the throughput, the latency, and the bandwidth delay product. Okay, very easy. Again, they're all related. Let's discuss. Let's start with bandwidth. Bandwidth, I've said it before. I'm going to say it again. Think about it as the window. Bandwidth is the window. So the window that I'm allowed to use. So this is the window. Think about it like that, and you will never forget this. It's not basically how much I'm sending. It's basically how much I'm allowed to send, which is completely different, okay? So this is the window. Again, it could be analog. It could be analog or digital. We'll talk about analog digital more later on, of course. But typically, when I say analog digital, when I say digital, I'm saying bits. When I'm looking analog, I'm saying signals. Therefore, it's all about the units. So of course, when I say analog bandwidth, I'm talking about hertz. When I say digital bandwidth, I'm talking about bits per second. Okay, hertz versus bits per second. So yes, it could be hertz, basically how much I'm allowed to send, which is the range of frequencies in a signal that that can pass. So one more time, analog bandwidth is the window I'm allowed to use in terms of hertz. Hertz is a unit of frequency, meaning what frequencies can you use? That's how I define it in analog. In digital, as you would expect, it's basically bits per second. Is how fast can I send? How many bits per second am I allowed to send? One more time. Here we talk about signals. Here we talk about signals. Hence, it's analog. Here we talk about bits per second. Bits. Zeros and ones. Okay? Bits per second. That's how we define bandwidth. Okay, it's not one instance harsh. Again, you can see per second. How much I could send per second. It's not one instance. How many in 1 second I could send. Okay, that's the unit. And I love it. I love it. I like when people ask questions. Again, I like when they ask clever questions. So bonus point for harsh. And don't be too harsh on us. Okay. So bonus point for harsh. And what else? Anybody ask a clever question? Let me see. So bandwidth is not for checking how much speed we get. Bandwidth is not for checking how much speed we get. Yes, it's not for checking how much speed we get. Bandwidth is for figuring out how much I'm allowed to send. Speed is throughput, which I'll be talking about in a second. Okay? Very good. Thank you so much, Alan. Okay, just checking out the chat if there's anything I missed. Okay, let's move on. So the bandwidth of a subscriber, okay, for example, let me give you an example. A bandwidth of a line is 4 kilohertz for voice. It's 4 kilohertz. Again, one more time. Bandwidth unit is hertz or bits per second. If you're looking analog, it's hertz. If you're looking digital, it's bits per second. The bandwidth for the line is 56 kilobit per second. So one more time, 56,000 bits per second, meaning 56 kilobit per second. You can see one more time, it is 4 kilohertz analog, and it's 56 kilobit per second digital. These are the same. One is in terms of what are the frequencies you're allowed to send. Basically, it's between 0 and 4,000 hertz. This is what this means. This is my bandwidth. My bandwidth is how much are you allowing. Anything in the range of 0 to 4,000 hertz will be allowed to transmit it. That's what this means. And this means that I can send basically 56,000 or 56 kilobits. I can send them per second. Okay? So these mean the same thing. One in analog and one in a digital. Subscriber line is the line. It's basically the DSL, the digital subscriber line. It's the cable that you connected to the internet for it. That's a subscriber line. Okay? Yeah, it's not what you're sending, Sufyan. Is what is the frequency of the signal being sent. You're not sending 4,000 hertz. You don't send hertz. Is what are the frequency of the signals that are being sent in your channel. You are allowed a maximum frequency of 4,000 hertz. Anything between 0 and 4,000 will be allowed. Anything below 0 or greater than 4,000 will not be allowed, of course. There's nothing below 0, but more than 4,000. Okay, so okay, because it was designed for the human voice. If anybody asks you, why 4,000? Because of the human voice. When the phone line was created, we use it for voice, and the human voice cannot go beyond 4,000. Therefore, they decided, you know what? Let's make the frequencies allowed on a telephone line 4,000, because we don't want noise, we don't want junk. But they never thought that the day will come where we will be using the telephone line in order to send data. And that's why we kind of changed the technology as years passed. That's the reason behind it. Okay? Very good. Very good. So let's do another example. Again, if a telephone company improves the quality of the line and increases the bandwidth to 8 kilohertz, you could see if I increase to 8 kilohertz, you could expect I could also increase how many bits I could send. It was 56. I doubled it, right? 56, I doubled it. Very easy. Of course, if you give me more frequency, you give me more bits. Common sense. If you increase the window, if you make a big window in my house, I could send and receive more. So if I made the window bigger, I could send and receive more. That's the bits per second. Okay? What we are sending is throughput, my friends. Just be patient a little bit. I'm going to talk about it. Don't worry about it. Okay? Okay, Harsh? Sorry. Are we good with bandwidth? Are we good with bandwidth? Analog, digital, bandwidth? Are we good? Please talk to me. Thank you so much. Thank you, Harsh. Thank you. So let's move on. So what are other performance measures that we'll be talking about today as well? You have utilization. Let's talk about them in general before we talk about them in terms of networking. Utilization, throughput, response time, and delay. Let's think about them a little bit. Utilization. Again, you should know this in English. What does utilization mean? Common sense. What does utilization mean? In normal thing, if I say I'm utilizing something, so what does it mean? I'm utilizing you, or you're utilizing me, actually. What does it mean? Utilization is the percentage of what? Come on, guys. Percentage of what? Okay, a lot of people are Googling, I think, or something. So let me just say it. So, of course, again, in English, if I said, okay, so you have it down. Sorry, I wasn't seeing the chat. Percentage of usage, productivity, yes. Saturated. I have a lot of good answers here. So, yes, typically utilization is how much I'm keeping the system busy. Okay? The percentage of time I'm keeping a device busy servicing a customer. So typically this is what utilization means. Of course, I could tell you what does network utilization mean in a second. But for now, utilization, how much I'm keeping it busy. Very easy. Throughput is how many jobs I'm executing. How many jobs I'm executing. Response time is the time required in order to receive a response. And finally, delay is the time to traverse from one end to the other end. Remember, these are definitions not related to networking, related to computing in general. I'll give you definitions related to networking in a second, but I want you to understand, very simple. Utilization is like, I am utilizing my coffee machine 80% of the time. What does it mean? What does it mean? It means I'm using it 80% of the time. So utilization is the percentage I'm using something. Percentage I'm keeping it busy. Throughput is how many jobs. Let me just tell you. These are general definitions. In networking, if I want to put networking here, you can see it's the same thing. Here saying that the percentage of time I'm keeping the device busy. Networking is the percentage of time I'm utilizing the network. Throughput is how many jobs per unit. Is networking is how many bits per second I can send. You can see? So the definitions doesn't change much when I talk about networking. Same thing with response time. The time I should wait for me to get a response. Response time and delay. No, it's a bit different, okay? Delay is the time for the message to leave a good question and go to B. It arrives here. This is the delay. The response time, no. It's I make a request, any kind of request, and I get the response. So B is responding. B is responding. Okay? So delay, B did not respond. It's just a delay it takes for the message to get to B. Response time is for B to respond to my request. Okay? Good question, Sufyan. If you could put it on the public, please, from now on, your questions, because it feels like I'm talking to myself. The others would not understand what I just answered. Okay, thank you, Sufyan. Okay, good. So again, in terms of networking, you can see there we had utilization. Here we have network utilization or channel utilization. It's basically how much I'm utilizing the channel. Is the fraction of time I'm keeping the channel busy. It could be 80% and so on. So you can see utilization and efficiency are very similar. The difference is when we take overhead into account, we talk about channel utilization as efficiency. So Some people even call it the same. Utilization and efficiency, almost the same. The only difference is utilization does not take overhead into account. So it only looks at the useful bits. Utilization doesn't. So again, very similar. So for you, think about them as similar, but the difference is when we look at the overhead, the extra. So basically, you have to remember, I'm sending information. This is what I'm sending. Okay? This is what we refer to as the useful bits. These are useful. These are things I'm sending. Of course, we also have overhead. This is what we refer to as overhead. The extra information that we add. Why do we add them? For example, who is the sender? Who is the receiver? Maybe a checksum, something that we add to make sure there's no mistake in my message, something for security. A lot of information. This is what we refer to as the overhead. My message is this, and these are what we refer to as overhead. Now, if I take overhead into account, so I look at these, you know, I exclude them from the useful bits, then we are looking at efficiency. If I don't, if I look at the whole thing, then it is considered utilization. Okay? Throughput is how many bits per second am I sending? One more time. Sending, transmitted, sending. If I want to look at, okay, Fatima, I'll do that. Let's just finish this. How many bits per second am I sending is what we refer to as throughput. How many bits per second I'm receiving is what we refer to as, who could tell me? Bonus point. I mentioned it before. Anyone? Okay. Good put. Okay. I mentioned it. The lecture is till 1:30. Okay. So how much I'm sending is good throughput. How much I'm receiving is good put. Okay, guys? So Fatima asked me, can I repeat this? I'm going to repeat it really quick. You could watch the video again, Fatima, but I'm going to repeat it really quick. One more time. When I'm sending a message, I have the useful bits. This is what I'm sending. And then I have also overhead. This is what we refer to as overhead. Again, the overhead is basically the extra information that we are sending. Okay, Fatima? So now, typically, utilization will come and say, okay, if you want to calculate utilization, I will look at this whole thing together and see how many bits you're sending, not useful bits, how many bits you're sending, and based on it, calculate the utilization, how much you utilize the channel. Now, if I remove the overhead, okay, I only look at the blue thing, then this is what we refer to as efficiency. So efficiency is more accurate to an extent. It doesn't look at the junk bits that, you know, we don't care about too much. It only looks at the useful bits. Okay, Fatima? Is it better? Fatima? Okay, excellent. Thank you, Fatima. I mean, if it's not better, please go back to the video. I'm sure we kind of figured it out. Okay?
No, it's all clear. Thank you.
Thank you so much, Fatima. Thank you. So throughput, again, and good put, I said how much you're sending, how much you're receiving. So if you look at it now, for 1 second, what we've talked about, we have the bandwidth. What is the bandwidth, guys? Remind me, what is the bandwidth? So to summarize what we talked about so far. No, not the rate we're sending. Come on, no. What's the bandwidth?
How much information is transferred in like a amount of time?
No, it's not.
Yeah,
That's what I told you.
hello.
Yes,
Yeah.
what's the bandwidth?
It's the amount of bits that you're allowed to transfer.
Yes, allowed to transfer. Thank you so much, buddy. Thank you. Smart. The window,
Yeah.
right? Think about window. The bandwidth is the window. How much I'm allowed, not how much I'm sending. How much I'm allowed. And the throughput is, so bonus point for Sufyan Brook, okay?
The
Bonus
speed.
point for Sufyan. Yes?
Throughput is the speed.
Yeah. So which one is bigger, throughput or bandwidth?
Bandwidth.
Of course, bandwidth. Of course.
Bandwidth.
Thank you so much. So throughput is how much I'm actually allowed, how much I'm actually sending. Bandwidth is how much I'm allowed. Okay. So you will see it now in a second when we do calculation for you to understand. Of course, bandwidth is always the biggest. Kind of the upper bound. Think about bandwidth as the upper bound. Okay, of throughput. Okay, so a network with bandwidth of, let's do this, 10 megabit per second. We're going to do some calculation. Get ready. And then I'll take a break and then do the last part of today's lecture, okay? A network with bandwidth of 10 megabit per second can pass only an average of 12,000 frames per second per minute, with each frame carrying an average of 10,000 bits. What is the throughput? Okay, so the window, what's the window, guys? Is how much? How much? 10 mega
10 megabits per second.
So I'm allowed to send 10 megabit per second. Let's see how much I'm actually sending. Can pass only an average of 12,000 frames per minute. So with each frame carrying, so we have 12,000 frames per minute. Okay? Which each frame carrying an average of 10,000 bits. So we have here, every frame of these guys is 10,000 bits. 10 to the power 4 bits. You see? Very nice. I like it. So every frame is 10,000, meaning 10 to the power 4. Please, when you do these calculations, get used to it. Don't write 10,000. That would be very stupid. Do 10 to the power 4. Don't put a million. Put 10 to the power 6, because the numbers will get bigger and bigger, trust me. You will get 15 zeros, you know? Like exabytes. Exabytes, how many zeros? Anybody? You remember exa? Is it 12 or 18? 10 to the power 12 or 10 to the power 18? 18, right? Or 12? You forgot already? Okay, let me remind you. Again, I want you to refresh, tattoo these metrics somewhere in your body, okay? You need to know these, okay? As you could see, 10 to the power 18 is exa. Zeta, 10 to the power 21. Iota, 10 to the power 24. Just remember these, you never know, okay? Going back. Sorry, where was I? So, one more time, 12,000 frames per minute. Every frame is 10,000, very easy. So the first thing we'll be doing is replacing the frame with 10 to the power 4. And then per minute, we know what minute, every minute is 60 seconds. I want to find the throughput, so very easy. So throughput is 12,000 frames per minute. I always recommend putting the unit, please, so that you don't get lost. Put frames per minute. Every frame is 10,000 bits times 10,000 bits. Who could tell me? Come on. 10,000 bits per what? 10,000 bits per what? No. Per frame. Yes, bonus point. Who said it? Per frame. You see? This is super nice. Why did I do it this way? Because whoever said frame, you get a bonus point, huh? Because frame will cancel frame. When you put the units, you will never do a mistake. You would see the final answer will be, if I convert minutes to second, because I have 60 seconds per minute, right? So I will cancel minute and minute. So I will get the final answer will be how many megabits or bits per second. Okay? So long story short, I'll do it one more time. 12,000 frames per minute with an average of 10,000. So I'm going to multiply 10,000 by 12,000. And I need to convert the minutes to seconds. So I divide by 60. The final answer will be 2 megabits per second. Very easy. I mean, this is very trivial. Obviously, I would not ask something like this in the final. But it's very trivial. It's just multiplying two numbers by each other. Okay? But I want you to understand, the window we had is 10 mega, but my throughput is 2 mega. So how much am I utilizing? How much am I utilizing? My bandwidth. How much? 20%. Thank you. Thank you, guys. Thank you. 20% utilization. 20%. Because we had it per minute. That's why. Per minute. Per minute. That's why we divide to second. Because the unit here is second. Okay? That's why we divided it by 60. Okay? I mean, you don't have to, but of course, you're going to get a lot of zeros here. The answer will be, if you multiply this in a calculator, if you multiply and divide in a calculator, the answer will be 2000000. Okay? Which is obviously very bad. So it's 2 mega. This is a million. 10 to the power 6. You don't have to convert, but of course, if it's a multiple choice, it will be already converted. But it's common sense to convert. Okay? Okay, guys, any other question? Okay, let's do more examples. What is the propagation time if the distance between 2 points is 12,000 kilometers, assuming the propagation speed to be 2.4 times 10 to the power 8 meter per second? Okay, so now we're talking about delay. I'll be talking about it more, but again, this is basic stuff. So if I have the distance between A and B, and I'm sending a packet, okay? A computer is sending a packet, go from A to B, right? You have many different kinds of delay. Yeah, after I do these couple of examples, we'll take a break, okay? I need a break more than you, trust me. But let me just do a couple more examples, okay? If I'm sending a packet from A to B, and there is a distance of 12 times 10 to the power 3 kilometer, okay? And the speed of the signal is 2.4 times 10 to the power 8 meter per second, okay? The first thing I would do, you need to convert everything to the same unit. So kilometer to meter, what should I do? Kilometer to meter, so what's the answer? Times 10 to the power? If I want to convert kilometer to meter. Yeah, so it's going to be 10 to the power, the final 10 to the power. It was 10 to the power 3 here. The final 10 to the power 6, thank you. 10 to the power 6 meter. That's the first thing I need to do. And very easy now. So I have the distance is 10 to the power, 12 times 10 to the power 6 meter between these two guys. The speed, this is basically the speed, the velocity of my signal is given. The question is the propagation time. How long would it take? Time. The time is very easy. Look at the units. It is distance. The speed is distance over time, right? So if I were you, I always put the units. I will never do a mistake. Make sure that the time has to be in what? Time has to be in what? The unit. Second. So I want my answer to be in second. So you need to make sure the units cancel out. So I have 12 times 10 to the power 6 meter. That's my distance. If I divide it by my speed, You don't need to memorize formulas. No need to memorize anything. Meter, look at this. Meter per what? Meter per
Second.
second. Right? And basic math. What will cancel what? Who could tell me in terms of unit? What will cancel? Meter will cancel meter, right? And second, that was down. What will happen to it? It was down. So it was in my denominator, double denominator. It will go all the way up. So my final answer is in seconds. So it's going to be something in seconds. Okay? You get it, guys? So please, I want you to be comfortable with this. I don't want you to memorize any formula. Again, I know the formulas, and many of you maybe know the formula. But if you look at the units, this is where all the magic is. You will understand how things are going. So I divide my time by my speed, and you look at the unit, very important. This is how we knew the answer, okay? So yes, let's do that. So this is what we did here, 12,000. We converted it to meters. And this was meter per second. Let me put the unit here real quick. So this is in meters. And this is in meter per second. So the answer will be in second. Of course, you could convert it. So I think the answer will be 0.05 second, is it? So, and then we can, if you want to change it to millisecond, if I want to change second to millisecond, second is bigger. Second is bigger than milli. So I will multiply, not divide, right? So I could multiply this by 1,000 to convert it to milliseconds. So if I multiply this by 1,000, I will get this 0 here, right? It will become 50 milliseconds. If you want, okay? Again, one more time. Millisecond, if I want to convert it to second, I divide, because millisecond is smaller. I divide by 1,000. If I want to convert second to millisecond, I multiply. Okay, guys? Are we good? Okay, let's take a break now. I need it, you need it. Let's take a 10 minutes break. I see you in 10 minutes. Okay? So we come back at 12, 25 is fine. 12:25. Please be back. Thank you. Okay, so back to where we were. So we talked about propagation time, very easy how to calculate. Talked about throughput, bandwidth. What else? Okay. So what are the propagation time and transmission time for a 2.5 kilobyte message? So again, now we have two different times. Again, let's talk about this a little bit until we go and define them explicitly at the end of today, or maybe starting next week. So one more time, I have A, I have B, I have a message that I'm sending. Okay, the message have a size, right? So what you need to know, we have two different times, two different delays. One is called propagation time or propagation delay. So what is the propagation time? It depends on the distance and depends on the distance. That's what the propagation time and what? What else? Distance and how much I'm sending. Yes. Right? So depends on the speed, not the throughput. The speed, the distance and speed. Just in the same example now. Distance and speed. Speed of the signal. It doesn't have to do with throughput, Taha. Has nothing to do with throughput. We just did propagation speed now. You forgot it? This one. Propagation time depends on, this was distance. how far they are from each other, and the speed of the signal. Has nothing to do with throughput. Now, transmission time depends on throughput, basically, and the packet size. So this depends on how big my packet is, packet size, how big what I'm sending. If I'm sending a 1 terabyte file divided to smaller packets, how big is each packet? And depends on my throughput. How many bits per second am I sending? Again, remember, both of them are seconds. Propagation time and transmission time are both in seconds, of course. But one depends on distance and one depends on packet size and bit per second. Okay? Very interesting. Let's do it together. Very easy. Let's do it. So let's start with propagation time. We already did the propagation time. So what are the propagation time and transmission time for a 2.5 kilobyte? Remember, it's a byte. A byte's how many bits? Kilobyte. Thank you. So 8, of course. So we have to make sure we convert the byte to bits before we do anything. So we have an attachment in an email. 2.5 kilobyte email. If the bandwidth of the network is 1 gigabit per second, assume that the distance between the sender and the receiver is 12,000 kilometers, and that light travels at 2.4 times 10 to the power 8 meter per second. Very easy. Don't panic. Let's start with propagation time. Remember, we did it before. It's distance. Distance. Tell me the distance, guys. Come on. Distance. Distance. Are you typing or what's happening here? Like when I asked the question many times.
Speed.
Yeah, but what is the distance? I know, but I'm just saying let's do it together. Equal distance over speed. What is distance? 12,000 kilometer. Put the unit, please. Put the unit as it is. Keep it as kilometer first, and then we'll convert. Yes, but first of all, copy paste it. Copy it first, and then convert so that you don't forget. But put the unit. Okay, over what? Speed. What is the speed? The propagation speed, 2.4
Times 10 power of 8.
times 10 per 8 meter per second. Now we see, you say, oh my God, this is meter. This is meter, but this guy is kilometer. Just again, very easy. So let's replace this kilo, replace this guy with times 10 to the power 3, right? Replace it by 10 power 3. Why? We want meter over meter. I know, we're doing it now for this question, okay? So if you divide them, make sure things are fine, we can find the propagation speed. Now, to find the transmission speed, transmission time, as I said, it depends over, instead of having distance, we have packet size. Packet size. Instead of having propagation speed, we will have what? What's my denominator here for transmission? I have the packet size is my numerator. My denominator is how fast am I going? Basically my data rate, basically my throughput. My throughput, okay? How much I'm sending. Let's call it data rates or throughput. They're all the same. Basically, how many bits per second? Okay? Size in bits over bits per second. So the answer will be second, something second. Okay, guys? So you can see, don't panic when you see these questions. Very easy. Oh, I need to know the transmission time. How do I do it? I need to know the propagation time. How do I do it? Again, we did it here. Propagation time will be 50 milliseconds. Transmission time will be 0.02 millisecond. Be careful with the 8 because it's bytes. So you have to multiply by 8. That's why we multiply by 8 here. Everything else is simple calculation. You can see who is the dominant, who's the one. We have two delays. Which one is the one affecting our performance? Which one is more important, transmission or propagation? In this question, which one is more important? Propagation, yes. In this question, propagation is taking more time than transmission. Okay, why? Because our message was really short. Our message was only 2.5 kilobytes, which was nothing, you know? We could do the same question. I don't know if I have it. Yes, something similar. Same question. I changed the numbers. I said, oh, you know what? What are the propagation time and the transmission time? My message now is 5 megabytes. 5 megabytes. And everything else the same. If you do the calculation, you see now, with the 5 megabytes and making the data rate smaller, look at this. It's 40 seconds. So which one is dominant? Which one is dominant? Which was more important in this question now? Transmission. Thank you so much. Transmission.
40
You see,
seconds.
it depends on packet size and data rate versus distance and speed. Okay? Are we good? We all understood the difference between transmission delay and propagation delay? Transmission delay and propagation delay. Any questions about this? Okay, guys? We are good. Excellent. All good. Thank you. So, again, now, let's look at the relationship. Suppose the bandwidth we're allowed to send is 1 bit per second. So they're allowing us to send 1 bit per second. And the end-to-end delay, so one more time, from here to here, the delay for the bit to get there. So when I'm sending, the time it takes the bit to arrive at my destination, the time it takes it's 5 seconds. And the window that I have, the window that I'm given, this is my window. How many I could send? In this example is 1 bit. So I'm allowed to send 1 bit in 1 second. And the delay, meaning the bits are going one at a time. Every 1 second, I'm sending 1 bit. Every 1 second, I'm sending 1 bit. And the delay for the first bit to get there is 5 seconds. The question is, how many bits can leave the source on the way to the destination by the time the first bit gets there? Very easy, right? So think about it. Basically, this is a good drawing. This is what we refer to as the bandwidth times delay product. So if you see, after 1 second, 1 bit leaves, right? Again, the end-to-end delay is 5. That was given in the question. After the second bit leaves. And the first bit is here. The third bit leave, and so on. You could see, obviously, after 5 seconds, I will have 5 bits in the pipeline. You could see them. These are my 5 bits. All these will be on the way to the destination. This is what we call the pipe, you know, the pipe, the product of the bandwidth and delay. We could do another question. Again, think about it as a pipe, and the cross section represents the bandwidth. So we always try to imagine like this. It's a pipe, it's a cylinder. Okay, the cross section, this thing basically is my bandwidth, you know, and the length of the pipe is the delay. The length is the delay. Okay, so now we can say the volume, basically how much I'm sending, how much I'm sending here is basically the delay times the bandwidth. We call this the bandwidth delay product. Very nice. Let's do one more question. Suppose I have now 5 bits and the delay is 5. You would expect it. How many bits will be on the way? How many bits will be on the way if I have 5 bits and 5 seconds? 25. 5 times 5. You can see it. You can look at it. 5, 5, 5, 5, 5. So a total of 25. Okay? Are we good, guys? Okay. So that's what we call the bandwidth delay product. Defines a number of bits that can fill the pipe or fill the link. Okay, this is the volume, as I said, length, cross section, you can see it defines that. Okay, finally, the last part of today is we're gonna kind of put everything together. So when I am doing analysis of network management, we are looking at a bigger network. We're looking at multiple gateway, multiple switches, sending back and forth, not like how we did it now. Here it was so simple. It was like, you know what is the transmission time if you're sending this? What is the propagation time if you're sending this? We did not have anything in between. It was simple as A all the way to B. Now, what if we have C in between and D in between before I get to B? What does that mean? What does that mean? It means that we have to calculate what? Who could tell me? Now, the delay from A to B, this line is no longer there. Suppose this line is no longer there. The delay from A to B will be what? The delay from where to where? Bonus point, come on. The delay from A to B will be what? The delay from? Somebody smart. Well done, Abdelrahman. Bonus point. The delay from A to C plus the delay from C to D, then finally the delay from D to B. So I have to do the calculation basically 3 times in this example. I have to do the calculations 3 times. Bonus point for Abdelrahman. I have to do the calculation 3 times in order to find the propagation delay, to find the transmission delay. So obviously, many times we assume they are equal. We assume the delays from here to here is equal, from here to here is equal. We make that assumption because these are very far from each other, you know? So that's something we'll be talking about now. So everything we talked about now still applies. The only difference is we need to look at the bigger picture. We need to look at the bigger picture. It's not only from A to B, is let us see what's happening in between, okay? In order to analyze the delay. You say, who cares? We care. Of course, when we're doing network design and analysis, we need to figure out what's causing the issue. You know, sometimes we might kill a router. We might add a router. We might add a switch. We might add a repeater. We might double we might put a limit on the packet size. So all the protocols that we'll be teaching you are based on performance, you know, and we need to look at these performance issues and metrics. Okay, back to the thing. So this is a typical example where we do something, many examples you could see. We have access point here. We have A, for example. A wants to send supposedly to H. You could see that the one in red. We're going to talk about this. So it's going to go 1 to 14. 14 to 15, 15 to 17, for example, 17 to 6, until it comes to H. So let me see if you remember. What is this cloud called? What is this cloud called? What do we call this cloud? Bonus point. Subnet. Yes, bonus point for Taha. Subnet, of course. We call this the subnet. So who could tell me how many links are from A to H within the subnet? Within the subnet. How many links from A to H? Bonus point. How many links from A to H? 4. Why is it not 5 or 6? Why did we not count this? Why did we not count this link, this one, or this one? Why did we not count it? Who could tell me?
Is it because it's outside the subnet?
Thank you so much. These are basically, let me explain it in a better way. These are, how far do you think this link would be, distance-wise? In meters, right? It will be typically in meters. You know, because this is a computer and this is like a big switch. Now, between this and this, we're talking about kilometers. You know? So obviously, when we're doing analysis of the subnets, we don't look at the hosts. We're looking, again, these 1, 2, and 3. These are, again, gateways, switches, very big devices. You know? So this is very important. Yes. How many? As you saw, it's 4 in this case. We do not count this. We do not count this. Just so that it doesn't become tricky for you. We only focus on the things within the subnet. So now if I want to analyze the delay from A to H, I need to analyze the delay from 1 to 14, 14 to 15, 15 to 17, 17 to 6, and finally, that's it. So we assume they are equal. So if I analyze one of them, I would typically multiply it by 4 in order to get the final answer. We'll be doing some examples on it. Okay? Very good. So what kind of delays are there? So we have some other delays. So we already talked about 2 kinds of delays. What are the 2 delays we talked about so far? What are the 2 delays we talked about? One was called, guys, what are the 2 delays we talked about? Propagation
and transmission.
and transmission. Thank you so much. These are the most common. These are the most common delays that we already calculated. Okay. Now the 2 others that we did not talk about, one is called the processing delay. And one is called the queuing delay, which are not always there, huh? The queuing delay. The queuing delay. And the processing delay. So what are these delays? These are so simple. Now, if I'm sending, again, go back to the example we had. So here, if I'm sending a packet here, when it comes to this router, this is what we call the queue. There might be packets ahead of it. There might be P1 here, P2 here in my queue that I'm still processing. So your packet could be here. So what will happen? So I need to process. I need to leave. I need to make sure packet 1 leaves my queue, gets transmitted, and packet 2 gets transmitted until I actually look at your packet, until I try to transmit it. So this is what we refer to as the queuing delay. Of course, queuing delay depends on traffic. So we have the transmission delay is the time it takes me to transmit all your bits. So if a packet depends on the packet size. So the transmission delay is the time for all the bits in the packet to leave my queue. That's what we call transmission time. Propagation time is the time for the bits to propagate on all the way to my destination. So it depends on distance and speed. Queuing delay, it depends on how many packets are in the queue when I arrive. Okay, so it's basically the queuing delay. Who could see? Let me give you a bonus point. You'd be very smart if you know this. The queuing delay is basically how many packets, number of packets, right? Number of packets in the queue times what? Who could tell me? Times what? See if you're clever. Times what? Number of packets in the queue times, not the processing time. Processing time is the time for me to process you and put you in the queue. Times what? What delay? No, guys, you're putting everything on the chat. Please think for 1 second, please. I know you will understand it in slow motion. If you watch the recording, you see I already gave the answer. So I came to, the packet came to you. The queuing delay is how much I'm going to wait in the queue. The waiting time in my queue, in the queue, depends on how many packets are in the queue until they get transmitted and leaving the queue. So I need to transmit them. I already wrote it here. So times what? Come on. Transmission delay.
The
Thank
time
you.
it took for the transmission.
Yeah, transmission delay. Exactly. Okay, like they typed it. Excellent. Thank you so much, guys and girls. Excellent. So yes, obviously the queuing delay is basically how many packets ahead of me and the time to transmit them for them to leave the queue. Guys, you need to understand these. I know it might become a bit tricky, but trust me, if you understand them, you're the king. I have students I've taught 15 years ago. They still call me today and say, thank you. You made my life hell, but thank you. I understand these things. It's not something I just memorize and do a quiz. وخلاص, I'm done. Okay, so please try to understand them. Really, it's very important. So yes, indeed, queuing delay is nothing other than the transmission delay, assuming they're all equal, assuming they all have the same equal transmission delay. Usually in exams or in analysis, we assume they have equal, because I don't want you to calculate them one by one. I would say you have 5 packets, find the transmission delay and multiply them, just to make your life easy. Now, if they were not equal, I have to add them, do the delay for each one of them separately. Until they leave the queue, they have to leave the queue. So that's what the queuing delay is. You say, what is the processing delay? The processing delay is mostly negligible, but basically it's the time for me to look at the packet, and put it in the queue. That's it. So I want to say, a packet came, okay, welcome to me. I put you in the queue. That's what we call the processing delay. I process it. I look at the packet and I process it and put it in my queue. So the time it takes for me to get the packet and put it in the queue is what we refer to as processing delay. Okay, so this is an example. You can see the packet coming in. It comes in to the queue and leaves the queue once everybody ahead of it actually got processed. This is what we refer to as the end-to-end delay. So what are the end-to-end delay? Look at them, 4 things. Can you remind me what are the 4 things? What are the 4 things we talked about? What are the 4 delays? Come on.
Transmission delay.
Let's start with the first one. Processing delay, to process it and put it in the queue, right?
Yes.
Then queuing delay, how long I'm going to wait in the queue. Then
propagation delay.
No.
Transmission.
Of course, transmission, right? Transmission, I need to transmit you and you leave my queue. And then
Propagation.
Then propagation. Thank you so much, Sufyan. Bonus point for you. So one more time, it's good to know the order. One more time. It's like a story. One more time.
Who was that?
Sorry?
I didn't see the name. Who got the bonus point?
I think Sufyan.
Sufyan, okay.
Okay. So you're helping out Brooke, right?
Yeah. We just
Yes, sir.
yeah.
So my assistant has an assistant now.
Yeah, that's how it's going.
Okay, so let's go through this one more time. The packet goes, as you could see. When the packet comes in, the first thing I need to do is assign it to the queue, right? This is what we refer to as what? Who could tell me? To assign it to a queue. What kind of delay is that? Processing. Thank you so much. I'm taking my time with this. You see, I'm repeating it many times for you to see. Most of the time, this is negligible. This is super fast. But still, we need to take it into account. Okay, now I'm in the queue somewhere. I'm in the queue. There might be nobody ahead of me in the queue, but there might be. Suppose there are people ahead of me. There are packets ahead of me. So I'm here. Okay, if I'm here, therefore, I have to wait. The waiting time is what we refer to as the queuing delay. Thank you so much. Let's call it QD. Let's gonna call this PD. Processing delay and queuing delay. Very good. So I'm gonna wait. And again, remember that the queuing delay basically depends on what and what?
Mission, like they need to be transmitted.
Yeah, and depends on the number of packets.
Oh yeah, number 4.
Ahead of me in the queue times the transmission delay of each one of them. Why transmission delay? Because they need to leave. They need to be transmitted. Okay, now it's my turn. I'm here. I'm X. So it's my turn. So I'm done with the queuing delay. What's the next delay?
Transmission delay.
Transmission. So I need to be transmitted. I need to leave this queue. I need to leave this router. This is a router. It's a switch. Could be a gateway as well. A big one. We'll be talking about networking equipment. Hopefully you'll be seeing them, the plan, hopefully on campus, we'll see. So transmission delay, I need to leave. I'm leaving. And finally, I left the queue. Where am I? If I left the queue, I am on the cable now, right? I'm on the cable. So the next thing will be, I'm on the cable. I need to get to the next router, is what we refer to as the propagation. I need to propagate from one end to another. See how cool? Very nice. All these delays. So if you are pinging, when you ping something and you see the delay, basically you are looking at all these delays. Yeah, don't get lost on the cable. What do you mean? The packet doesn't get lost, or Muhammad? What do you mean? I don't understand. Yeah? I didn't understand the question. If you could clarify it, let's move on. So yeah, so these are the delays. Let's go over them one more time. These are the delays. Again, remember, with the end-to-end delay is the summation of all the delays. If or if they're equal, I multiply them. So if I need to do this for each one of the hops, okay? For each one of them. So if they are equal, I will multiply. If they're not equal, I need to add them. So I have to do the end-to-end delay multiple times. So what are the delays? One more time, we have the processing delay, which I told you is a time for me to take your packet and put it in the queue. The queuing delay is a time for me to wait in the queue until all the others get transmitted, all the other packets. The transmission delay is the time the first and the last bits of the packets are transmitted. So it depends on, let's write it one more time, depends on two things. What does it depend on, transmission delay? What does it depend on?
Number of packets.
No, transmission delay. Transmission delay depends on
The
size
and the width.
and data rate, not on bandwidth and data rate usually. Sorry. Size. Now, assuming if the bandwidth is equal to the data rate, that's fine. So, and throughput or data rate. Data rate is throughput, how much I'm sending. And the propagation delay depends on two things also. What are they? What are they? Propagation, distance, and speed. Thank you, Alka. Bonus points for Alka. And also Abdurrahman, because they said it almost at the same time. Oh, actually, many people said it at the same time. No, okay, no bonus point for any. Because many people said it, okay? So distance and speed. Okay, so remember these, and we're going to do an example now together. So the link delay, remember one more time, the link delay is all these four, and the end-to-end delay, is the sum of all the link delays. So one more time, so if A goes to B, this is called the link delay. We have to do these. Then B goes to C, this is another link delay. Then we have to do these again. And then C goes to D, suppose, another link delay. Then we have to do these again. However, to make your life easy in this course and in life, most of the time we assume these are equal. So if I want to find the end-to-end delay, end-to-end. So end-to-end delay is going to be equal. And suppose we have n nodes, n switches in my subnet. N switches. Who could tell me? Bonus point, definitely bonus point, the first one. What would the end-to-end delay be? The end-to-end delay is basically the link delay, assuming they're all equal. The link delay times what? No, not n.
Processing delay.
No, of course not. Link delay is processing, queuing, transmission, and propagation. Times what?
Is the number
Some
of
people came
packets.
close. Times n minus 1. Thank you, Devraj. Times n minus 1, of course. Come on, look at the picture here. You didn't see it? Look at it. A, B, C, D, right? How many are they? 4. How many link delays did we have? How many link delays did we have? 3. So it's always n minus 1, of course. So yes, the link delay is n minus 1. N minus 1 times link delay is basically the end-to-end delay, assuming they are equal. Assuming they are equal. Okay, amigos? Are we good? Are we good? Any question? So let's do one nice example and we'll be done for today. I'm exhausted, you're exhausted. But I think we took our time. Please make sure to watch the video again in case any questions. So let's do an example. The only way for you to learn is doing an example. Okay, so before we get there, so we have other measures. Latency is basically minimum delay. So we talked about throughput, bandwidth. What else? We already talked about latency. Latency is the minimum achievable delay. What's the minimum delay? We refer to it as latency. Good put is like throughput, but the difference is throughput is how many bits you can send. Good put is what? Is how many bits you can receive. Thank you so much. Receive. This is receiving bits. Fairness, again, how fair am I? So this, some people look into it, meaning I don't want to use one router more than the other. I want to try to be as much as fair as possible as I can be. We call this load balancing as well. And quality of service, QoS, it's a general term. We use it for multimedia usually. An example we did in the tutorial, an example of multimedia quality of service is called jitter. Yes, thank you. Jitter. Bonus point for you, Reda. Jitter. Okay, jitter is a good example of quality of service measure. So yeah, these are quick definitions. I kind of talked about it. The minimum possible delay is latency. The good put is how much I could receive. So it's measured at the receiver, not how much you can send. The fairness is, again, as I said, load balancing and treating everybody fairly. And quality of service is usually, we use it for multimedia, a metric to decide on the quality of our transmission. So these are things you could see. Remember them, you might come across them later on. So let's do one example and I'll be done. I'm going to do only one example. In the tutorial, we're going to be doing another one example. So let's do this together. Very easy. Come on. I think by now this should be batata, but be very careful. Be very careful with your calculations, because some of you could be confused with the units. Don't panic. As I taught you, put it as it is. Take your time with it, and then divide the units. Okay, but make sure the units are consistent. Yeah, let's do this together. I'm gonna do it with my mouse. What is the end-to-end delay, packet delay in this store and forward from router 1 to 6? Oh yeah, this is what we had in the picture. Remember it? Let's go back. Let's go back to the picture. A to H. Remember it? This one. From A to H. This is what we're looking at, guys. See? So instead of looking at the whole picture, we drew it for you in a linear way for you to see the picture nice and easy in front of you. Our job is now to analyze the end-to-end delay. Okay? The end-to-end delay. Let's go ahead and do it. So we want to find, the end-to-end delay from A to H. First of all, how many links do I have in the subnet? Where is the subnet? This is the subnet, guys. Don't forget. How many links do I have? Yes, 1, 2, 3, 4. We have 4 links. So my end-to-end delay, basically, the first thing I will do here is end-to-end delay. It's going to be equal to 4 times what? Times what? The end-to-end delay is 4 times the link delay. Thank you so much, guys. Thank you for those who are always with me. The others, please pay attention. Thank you. That's the first thing I would do. This was an exam question. The first thing I will do is say, okay, so that I don't forget, the end-to-end delay is going to be 4 times the link delay. Now, what is the link delay? The link delay usually is 4 things, right? Let me put them down. Okay? It's 4 things. I'm going to put them under each other. Okay, I'm going to put them under each other. We're going to start with the processing delay plus what? And what comes after processing? The queuing delay, the transmission delay, and finally, the propagation delay. You see how organized I'm doing this? I love this. It doesn't make me confused. You take your time, say, oh, what are the delays? These are the 4 things. Step 1, end-to-end delay depends on link delay. Step 2, what is the link delay? We put them one by one. Yalla, let's do them together. Yalla. Gonna change the color. Let's start with processing. Let's read the question. Assume all the links are 2.5 kilometers. So we have the distance here. This is my distance. The C, again, C is capacity, which is basically my throughput. It's 100 megabit per second. Propagation speed is 200 meter per microsecond. Queuing delay and processing delay in this question were 0. They made our life easy. Good for us, 0. But they don't have to be in an exam. And we're going to do other examples when they're not 0. It's not a big deal. They're not 0, we put them. We find the answer. 0. The queuing delay, again, is 0. Okay? Now, the transmission delay, like we did before, depends on what are the 2 things the transmission delay depends on? What are the 2 things the transmission delay depends on?
Size and DPS.
Yes, thank you so much. Thank you, buddy. Thank you. Yalla, size. How big is the packet? 1,000 bytes. So the first thing is we need to do is 1,000 bytes. So I need to change it to bits. Okay? Again, put the unit. Very important. Put the unit. Otherwise, you'll be lost. Trust me. And then the data rate was 100 megabits per second. 100 mega. So again, you could convert it now if you want. Mega meaning 10 to the power what, guys? 6. Thank you. Mega meaning million. 10 to the power 6. Now we could put the unit. What would the unit be? Bits. The mega is 10 to the power 6. Bits. And write it like this if you want, please. Bits. And put over what? Second. You see why I did it this way, guys? By doing it this way, it really makes you see that you are on the right track. Because the bits will cancel bits, and the answer will be second. Whatever you get in second, do it in a calculator. You will get in second because this is the second. You see, the second went up. See how cool this is?
Professor,
If you do it, sorry?
Professor,
Yes.
can you explain what's the 1,000 bits? The 1,000 times 8 bits?
1,000 bytes. You see here the packet size? That's
Yeah,
it.
but what's the times 8?
Bytes. A byte is 8 bits, my friend. Bytes is 8 bits. 1 byte equal 8 bits. We all should know this, please. Okay. Very good. Okay, that's good. That's good. Ask questions. Fine. It's fine. Even if sometimes they're simple questions, it's okay. It's fine. I feel with you. Okay. Are we good with the transmission time? So we can do the same again. Make sure you do the calculation. Please don't do mistakes. Make sure you're comfortable with calculations. Propagation time, same thing. It depends on what and what, guys. Propagation time depends on distance.
Size and distance.
Yes, distance over speed. Distance over speed. Thank you so much. Thank you. Again, make sure you're comfortable. Let's go ahead and put them. Be careful with the units. I know you guys will panic and you wouldn't know how to do it. You say, oh, what if a computer can do it for me? Of course, a computer can do it for you, but the computer doesn't know units. No computer would know the units unless you go and one by one and explain it to it and write a program to do it. You know, so that's why you have to be a little bit comfortable. You could convert units using a computer, but to solve this whole problem, it has to be a human. Okay, because I could easily trick it and add some clever questions here and there. You know, I could add queuing delay in a clever way where you need to understand what the question is. So anyways, what's the distance of each link? 2.5 kilometer. Each link was 2.5 kilometers. So convert to meters. Convert to meter. What do I do to convert to meters? 10 to the power 3. Thank you so much. And put the unit, meter. Put the amp so that you don't forget it. Now it's in meter. Now over speed is 200 meter. That's fine. Per microsecond. Again, the unit of microsecond, the symbol is this, microsecond. Okay? So microsecond is this, in case you want to use units. So 200 meters per microsecond. So my answer will be in microsecond, which is fine. Make the answer in microsecond, no big deal. So let me clean up all this mess and show you a clean version. This is a clean version of what we did together. So the transmission time, if you divide them, you get the answer is 8 times 10 to the power minus 5 seconds. 8 times 10 to the power minus 5 seconds, which is what? It's 80 microseconds. How did we do that? We multiply this by 10 to the power 6. We can convert it to microsecond. It's easier to deal with this rather than this. Propagation time, same thing. If you divide them, you get it in microsecond. We are almost done. Add them together, you get the link delay is 92.5 microsecond. And finally, the end-to-end delay is 4 times 92.5. So we get the final answer. So you can see it's not difficult. If you organize your stuff, you can easily do this. Just remember the basic things I taught you today.